Welcome back. Problem 11-36. So statement is determine the variation of radius r of cantilever beam that support the uniform distributed load so that it has a constant bending stress throughout its length. So you can see this is the cantilever beam that is acted upon by this uniformly distributed load of W. The total length of this beam is L, clear, and this radius variate along x distance. So here it's given it is r, here it has r naught. So you have to find this variation of this radius r when you move along the x distance. So let's start with the solution. So first step is that if you cut the beam over a length of x, clear, and you will draw the free body diagram. So I will draw the free body diagram will be like this one, not a rectangular. It will be, for example, this. It should be like this. Okay, so you can see, oh, this is length x from the end, and here we have a uniformly distributed load. I will draw it like this. This has a uniformly distributed load having magnitude W, clear. And when you cut the beam over here, so definitely you will be having shear force V, and you will having a bending moment M. So we are interested in to find out this bending moment. So let this is your point 1. So now we will apply sum of all moment about point 1 is equal to 0, taking the counterclockwise moment as positive. So one moment is due to this distributed load. When converted into a point load, it will be W into X, and that will be acting at a distance of X by 2. And this will produce clockwise movement, so it will be negative, plus another external movement which is M, that is in counterclockwise, so its value will be 0. So I will represent this W when converted into a point load. It will be W into length, which is X, and that will be acting at a distance of X by 2 from this, or from other side as well, clear. So first moment will be W into X into X by 2. This is clockwise, so it will be negative, plus the external moment M. This will be equal to 0. So it means that this moment will be equal to Wx square over 2. So this is the moment. Now we know that maximum stress is equal to moment divided by section modulus. So you have moment, this you do not have section modulus, so section modulus is equal to I divided by C. So if you cut the beam over here, so definitely you will be having a radius which is represented as R, and this is your neutral axis. So I for this will be equal to pi by 4 r power 4, and C will be equal to, for here C will be equal to this R, because C is the maximum distance from neutral axis till the topmost, that is R. So you can just put over here pi over 4 R4 divided by R. So section modulus will be equal to pi R cube over 4. Okay, now you can just put it in this formula. I will choose another color. Maximum stress is equal to moment, which is Wx square over 2 divided by section modulus, which is pi R cube over 4. So when you solve this, you will get 2 omega 2 Wx square over pi R cube. So I will write it, sigma max is equal to 2Wx square over pi R cube. So this is the maximum bending stress for X, for this length, for this X length, clear. I will call it equation number 1. Now if you are interested to find out the stress at x is equal to L. Clear? Because x variate from here till, and it will be till L. So if you replace x will be with L, so definitely at x is equal to L we have this radius C is equal to R naught. So at x is equal to L, clear, we have C is equal to R naught, and C is equal to R as well. Yeah, at x is equal to L, radius is equal to R naught. Clear? So put in equation 1, put in equation 1, so you will have sigma max at x is equal to L will be equal to 2W L square divided by pi R naught Q, and this will be your equation number 2. Now in given condition it is given that maximum bending stress is constant throughout its length. So if you take the maximum stress at 1 or 2, maximum bending stress is constant throughout length. This is given in question. So it means that equation 1 is equal to equation 2. Equation 1 is 2wx square divided by pi r cube is equal to 2wl square over pi r naught cube. So this w will cut with 2, will cut with this, and we will left, we are interested to find out this r, and pi will cut with pi, so we will left r cube is equal to r naught cube into x square divided by L square. So this is the variation of, these are our radiuses. Outer radius, this is the radius at x is, so this is the variation of radius r of this cantilever beam. I hope you have enjoyed this video and you are learning from it as well. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.